You know the exact moment. You're deep in a session that's actually going well, the agent finally understands the codebase, and then the little bar in the corner turns orange, compacting. And you watch it throw away the last 2 hours and hand itself a paragraph-long note about what it just did. Everything after that is worse. It rereads files it already read. It re-asks questions you already answered. It resuggests the fix you rejected an hour ago. Nothing broke there. That was the architecture working as designed. The model has no memory. The loop keeps handing it the transcript, and when the transcript gets too big, something has to go. And you pay for every copy on the way down. At benchmark scale, it looks like this. 1 run, 200 questions, 221 million tokens. The obvious fix is a bigger context window. Except Chroma tested 18 frontier models and found the opposite happening. Accuracy fell as the input grew, and it started falling long before the window was anywhere near full. So in April, Tencent Cloud's database team pushed a different answer to GitHub under an MIT license. 10,000 stars in 4 months, and a benchmark table with 2 columns that should not both be moving. Same benchmark as the meter you just watched. Pass rate went from 33% to 50%. Token use dropped 61% at the same time. Better results on less than half the tokens, and the way they got there was by making the agent remember less. 2 questions. How does throwing information away make an agent smarter? And are these numbers real? I checked both, and one of them has a problem. An agent is less than most people assume. A model with no memory, plus a loop that keeps handing it the transcript. So the loop compensates by pasting everything back in. Files, tool output, errors, all of it. On SWE Bench, Tencent ran 50 coding tasks in 1 session and burned 3.5 billion tokens. The tokens are the cheap half. The expensive half is what all that text does to the model. Chroma's context ROT study ran across GPT 4.1, Claude 4, Gemini 2.5, and Qwen 3 on tasks a child could do. Copy this text. Find this sentence. As the input grew, they got worse at it, some by 30 to 50%. A 200,000 token window can start degrading around 50,000. The reason deleting things helps is that attention is a fixed budget. Every token competes with every other token for it, and that budget doesn't grow just because the window did. 50,000 tokens of stack trace next to the one line that matters gives the right answer 50,000 competitors. Cutting the noise raises the odds on the signal. That's the whole mechanism, and everything Tencent built sits on top of it, which is why the geography in the title isn't decoration. American labs sell context length because they have the compute to serve it, and it's a number you can print on a pricing page. The Chinese labs are shipping the layer that makes short context work and giving it away. When you can't win on raw scale, you compete on efficiency. The plugin has 2 ideas. The first is about the session you're in right now. In a long task, the token hogs aren't your instructions. They're the intermediate logs. Search results, stack traces, file dumps. So the plugin writes full tool output to markdown files on disk. What stays in the prompt is a Mermaid diagram of what happened, with an ID on every node. Hundreds of thousands of tokens of log collapse into a few hundred tokens of shape. When the agent hits an error and needs the detail, it grabs the node ID and pulls the raw text back. That's the constraint they kept. Compress, but never lose the road back to the evidence. A summary is one way, which is what the orange bar does to you. This is a folded diagram you can open again. At half the window, it compresses mildly, at 85% aggressively, and the canvas is capped at 20% of the budget, so the map never eats the room it's saving. Now the numbers. The headline comes from Wide Search, out of ByteDance's seed team. 200 questions, half English, half Chinese, and all of them wide rather than deep. The test is a pile of easy facts that all have to be right at once, which is exactly the task shape that fills a window with junk. Baseline solved 33%, the plugin 50%. Tokens fell from 221 million to 86, roughly 100 million words saved. About 170 copies of War and Peace generated and never read. While that table is up, do the arithmetic yourself. The SWE bench token columns divide out to a 31.6% cut. The row next to it says 33.1. Small, probably a normalization choice rather than a mistake, but it's their arithmetic and it's the one row that doesn't divide. The long context row divides to the exact printed number, which is the point. These figures are checkable, so check them. The harder benchmarks moved less. SWE bench went 58.4 to 64.2 on a third fewer tokens. On a long document test over real financial filings, 44 to 47. Smaller gains as the task gets harder. Hold on to that. The second idea comes out of a 50-year-old argument in psychology. In 1972, Endel Tulving split human memory in two. Episodic, the events you lived through with times attached. Semantic, the facts you know with the event that taught you them stripped away. You know, Paris is the capital of France. You have no idea which afternoon you learned it. The interesting part is the arrow between them. Episodes get replayed, patterns get pulled out, the episode fades. Psychologists call that consolidation, and hippocampal replay during sleep is one mechanism neuroscience has actually watched happen. Ebbinghaus measured the other half in 1885. Without review, 2/3 of what you learn today is gone inside a day. In that system, forgetting is the compression step. Tencent's long-term side is that arrow as 4 layers. L0 is the raw conversation. L1 pulls out atoms, a fact, a preference, a constraint, every 5 turns. L2 groups atoms into scenes, this project, this kind of task. L3 is the persona, your habits and defaults, rebuilt every 50 memories. The agent reads top-down, persona first, because it's cheap and usually enough, dropping to atoms when a specific fact matters, and to L0 when it needs your exact wording. Tulving's arrow, run backwards on demand. The benchmark there is persona mem, and it's nasty. Multi-session conversations where the user's preferences change, testing whether the model tracks the change instead of reciting the old answer. Baseline 48%. With the layers, 76. The plumbing is deliberately boring, which is a compliment. SQLite on your machine. No API key, nothing leaving the laptop unless you say so. One command to install into OpenClaw. Every layer is a file you can open, so when recall goes wrong, you read it instead of squinting at cosine scores. Before that matters, though, you already have a memory system. It's a markdown file you edit by hand whenever the agent annoys you enough. And for plenty of work, that's genuinely fine. The gap is coverage. Your file has the things that irritated you enough to write down. This one writes itself from what happened, whether you were paying attention or not. The trade is that a handwritten file never goes stale behind your back. A generated persona can drift for weeks before you read it, which points at a failure worse than the one you started with. When your agent forgets, you notice. It asks twice. You sigh. You tell it again. When it remembers something that stopped being true, nothing visible happens. It confidently does the thing you asked for in March. Retrieval misses are quiet the same way. The recall step returns the wrong 5 results. There's no error, and you get an agent that's mysteriously worse today. Then you blame the model. So I ran it, because the complaint I'm about to make is that nobody outside Tencent has. Your result here. What you pointed it at, how many sessions, what the L3 persona file said about you, your real token delta on one long task. Read the persona file out loud. Uncanny or generic, say which. One developer, one repo, so treat it as an anecdote. It's still more independent evidence than currently exists. Every published result came from the vendor. Mem0 published a paper ranking memory systems. Zep published a rebuttal saying it had been misconfigured and scored itself 9 points higher. Everyone benchmarks on a different dataset, so everyone gets to be first. Then there's the one that shows up on your bill. Issue 120. Injecting memory changes the front of the prompt every turn. Providers cache that prefix and bill identical opening tokens at a fraction of the price. Change the opening every turn, the cache stops hitting, and part of your saving walks back out the door. The maintainers have it open and unsolved, argued about in public, which is the version of unsolved you want. Worth seeing who's paying, too. The repo is MIT, and it does run local. It also ships a Tencent Cloud vector database backend and a managed memory service that launched 4 days before the repository existed. OpenCore with a cloud upsell. Version 2, in July, moves memory from a private cache to a shared team asset. Chat memory, skills, a wiki, and a code graph, each with an owner, a version, and permissions. Point it at an existing repo or your old sessions, and it backfills all of it before your agent does anything. Memory stops being a log and becomes an artifact with a license plate. That also opens something new. Prompt injection used to be per session. Poison the context, the session ends, the poison goes with it. Once an agent writes to a store your whole team reads from, a bad memory survives and gets read by your colleague's agent next Tuesday. Their tracker has an open issue about a search query that doesn't escape its operators, so user input can rewrite the query. Put those together and you have an attack surface nobody has tested. The strongest argument against all of this is that the category is temporary. Windows keep growing, long context handling keeps improving, and every memory layer you bolt on today could be dead weight later. I think Chroma answers that, because the degradation is about attention rather than capacity, and a bigger box doesn't fix attention. But if you believe the labs will solve long context properly, waiting is defensible. So install it. If you run long sessions, it's one command and defaults to local, so the cost of finding out is an evening. If you want the proven version, wait for someone outside Tencent to reproduce that table. And if you're evaluating for a team, the benchmark isn't the deciding number. Issue 120 is because caching is where the savings either survive your invoice or don't. The durable part doesn't belong to Tencent. Every serious memory system is converging on the same shape. Keep a sketch in context. Keep the evidence on disk. Keep the path between them intact, which is the thing the orange bar never did for you. Compaction throws the session away and hands you a note. Consolidation throws the session away and keeps the road back. One word of difference and an entire architecture. And it's what your own head does every night while you sleep, which is why you can remember how your codebase works without remembering the afternoon you learned it. If you want more teardowns where the arithmetic gets checked, subscribing is the cheapest way to get them. One question the roadmap hasn't answered. When memory becomes an asset you own, what happens when you switch frameworks or leave the team that built it? Portable memory is item 1, and the box is still unchecked. Tell me where you land. See you in the next one.